Hello student, welcome to Lotus High School. This is SR from the Lotus High School. Here we're studying a chapter in the science subject. The name of the chapter is Acids, Bases and Salts. So here the name of the chapter is Acids, Bases and Salts. So in this chapter, today we will discuss about the part 9 topics. So in the part 9, what are the topics are there we will discuss. So today's topic is chemicals from the common salt. So from the common salt, what chemicals will come? We are discussing that chemicals. So already in the previous video, we have discussed about the chemical of the sodium hydroxide, which is completely comes from the common salt. Which comes from the common salt we have discussed. Now this time we are discussing that chemical which is comes from the common salt. So see here, the chemical is a bleaching powder. So if you observe this bleaching powder is comes from that chemical of that chemical of that what is that common salt. What is that? Common salt. You already know very well that what is a bleaching powder. You know that use of the bleaching powder also. Everybody knows. Why? Because in our surrounding we are using the bleaching powder. So now we are discussing that how the bleaching powder is produced. That means how the bleaching powder is manufactured in the industry. And here we will discuss the uses of the bleaching powder, in which way the bleaching powder is useful to the human beings. So here and so these are the topics, today's topics. These are the today's topic, the production of the bleaching powder, and the second one is the uses of the bleaching powder. So see here. First one about bleaching powder. About bleaching powder. First, calcium oxychloride. CALCIUM, calcium OXYCHLORID, calcium oxychloride. Calcium oxychloride is commonly known as a bleaching powder. So here calcium oxychloride is a chemical name. And if you are observed this bleaching powder is known as common name. Already in the previous video I discussed the difference between the chemical name and common name. I told that the common name is called the pet name. So, if you are observed every person has two names. One is a registered name, that means in the school what name is entered in the register, that name, and afterwards in a home they will call it with the pet name. So like that, if you are observed this bleaching powder contains the two names. One is the calcium oxychloride and the second one is the bleaching powder. So calcium oxychloride is a chemical name and the bleaching powder is called a common name. So just like pet name. And here, second point, the chemical formula of the bleaching powder is CaOCl2. What is that? CaOCl2. So see here, OCl2 is known as oxychloride. What is that? Oxychloride. And here Ca is nothing but calcium. So calcium. So total calcium oxychloride, calcium Ca oxychloride OCl2. Okay. Next, it is basic in nature. Basic in nature. That means just you have to take that one red litmus paper and place the red litmus paper in the bleaching powder and observe it. Within a fraction of a second, the red litmus is converted into that blue color. So the substance which is converting that red litmus into blue, that substance is completely called the basic nature. Okay. So here about the bleaching powder, first point is the bleaching powder is known as calcium oxychloride and the chemical formula of bleaching powder is CaOCl2 and it has basic nature. Here 3 points are given. Okay, in the board examination the 3 points are given as a 3 marks question. Or sometimes the 3 points are completely split into the 3 points as a 1 mark question. So 1 mark question will be like this. What is the common name of the calcium oxychloride? So answer is bleaching powder. What is the chemical formula of the bleaching powder? And what is the nature of that bleaching powder? Simply how to tell the base of that bleaching powder is a basic nature. Okay, this is about the bleaching powder. Next, production of bleaching powder. So for making the bleaching powder, What chemicals are required? The chemicals are slake lime, not snake lime. Slake lime. Here, the slake lime is a common name and the chemical name is calcium hydroxide. So here, the chemical form of the calcium hydroxide is CaOH twice. What is the formula here? CaOH twice. And that another chemical substance is chlorine. So totally two chemicals are required for making two chemicals are required for making the bleaching powder. So first chemical is slake lime or calcium hydroxide, and that another chemical substance is chlorine gas. So here already know very well the slake lime or calcium hydroxide is present in that solid state, and if we are added it converted into the liquid state. But here you have to take the solid state of slake lime or solid state of calcium hydroxide. So to that slake lime, okay, just chlorine gas is added. That means the chlorine gas is slowly passes into the solid state of calcium hydroxide. So see here this diagram. Watch this diagram carefully. Why? Because depending upon this diagram, next video will be present. Here, okay, here it is present in this horizontal position, but in that video, if you are observe this one, if you are observe this picture will be present in the vertical position. Okay, okay. See here. So see here. This is the cylinder. Okay. So this is the first cylinder. This is the second cylinder. This is the third cylinder. This is the fourth cylinder. Okay. And here this is a blade, 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 or otherwise one kind of flat material. So simply how to call it the blades. So here this blade is completely placed on iron rods. So totally this set is completely called as shaft. SHAFT shaft. Okay, what is that one here? SHAFT shaft. So here in first cylinder one shaft, the second cylinder shaft, the third cylinder shaft, in the fourth cylinder shaft. Okay, and here if you are observe these shafts are always present in that rotating position. That means they will rotate like this, they will rotate like this, they will rotate like this. Okay, for how we are rotating the pencil, that means that shaft means, for example, take one pencil. In that pencil, okay, in that pencil here one thumb pin. Okay, here thumb pin you have to insert. So the total is completely looks like a one kind of nature, that is known as what here shaft. Okay, here that what is that, pins or safety pins, no problem, safety pin you have to insert it. So total it is completely looks like a one kind of shaft. So here if you are observe the shaft is always present in the rotatory motion. That means they present in that circular motion, rotatory motion, circular motion. So see here one opening end is present. So in this opening end, the slake lime will be placed. And with the powder state of slake lime is completely placed in this opening end. Now here the slake lime is falls on this shaft, and when the shaft is, so here when the shaft is rotating on that time, the slake lime will rotate on this shaft and afterwards it falls into that second cylinder. In that second cylinder it falls on that shaft, and that shaft is also present in that rotatory motion. So automatically it falls down, and here opening end is present. Through that opening end it will enter into that another cylinder, and in that one it falls on the shaft. Now when the shaft is rotating, the calcium hydroxide or slake lime is falls into this next cylinder. In that cylinder also what are present here? Shafts are present. Up to here, okay. Now see here, up onwards slake lime is placed. Down onwards chlorine gas, chlorine gas, chlorine gas, chlorine gas, chlorine gas, chlorine gas. See here, chlorine gas enter into the bottom position of the first cylinder. Next, it enter into the bottom position of the second cylinder. It enter into that third cylinder. Next, it enter into the first cylinder. Okay, it enter into the fourth cylinder. Okay, bottom to first or fourth cylinders up onwards. It enter into that fourth cylinder. Next, it enter into the third cylinder. It enter into that second cylinder. It enter into the first cylinder. So here calcium hydroxide, that means slag lime is present. Here also slag lime is present. Here also slag lime is present. Here also slag lime is present. So in which way the chlorine gas is going, in that way the slag lime is reacting with that chlorine gas, reacting with the chlorine gas, and automatically, okay, here reaction is present, here also reaction, here also reaction. So finally, if you are observe the bleaching pot is completely collected at the bottom position of the opening end, and here one up opening end will be present. Through that opening end, some waste gases will go outside. Okay, so this total process, actually we should not call it as a process, this is completely known as one kind of plant means not green plant. That means in the industries where the missions are present, where the missions are working, we are telling that is called the plant. So the name of this plant is HESCN Hessen Clever's plant. Hessen Clever's plant. So this plant is especially used for making of that bleaching powder, or this Hessen Clever's plant is useful for manufacturing of the bleaching powder. Okay, simple labeling, nothing. What is that one here? The slag lime is placed on that first cylinder. So it falls on the shafts. When the shafts are rotating, it will goes down, and next it enter into the next cylinder, next cylinder, next cylinder. Down onward, the chlorine gas will comes to the upper position. In the path of the chlorine gas, it is reacting with the slag lime and converting. Okay, reacting with that slag lime, and finally it converts the bleaching powder. That bleaching powder is completely collected at the bottom position of this plant. That means otherwise bottom position of this last cylinder. Okay, let's see the diagram carefully. Hessen Clever's plant. This is very very important. Why? Because the question will be like this: by using which process we can manufacture bleaching powder? So Hessen Clever's plant process. Okay, and here one more question is that chlorine gas is completely passes through the upward position or downward position. So downward position. Why? Because the chlorine gas contains lightweight. This is very very important question. So this is the serious important question. Why we should not send that chlorine gas in the upward position? We should not send that chlorine gas in the upward position because chlorine gas is not a heavier gas. If it is heavier, what will happen if it goes down? If it goes down, what here the chlorine gas is completely sent into the upward position. That means bottom to the upward position because due to the nature of lightweight. Already in the previous video, we have discussed that formation of sodium hydroxide, chlorine gas, and that hydrogen gas, H plus Cl minus. So H plus Cl minus, they contains lightweight, so they are moving in the upward direction. And afterwards, H plus is converted into that hydrogen gas. Cl is converted. Sorry, Cl minus is converted into the chlorine gas. So here, chlorine gas contains lightweight. So due to the lightweight nature, it is completely moves in the upward direction. So it's sent to the bottom position of the plant. So this is the main reason. Okay, the manufacture of bleaching powder is generally carried out in the Hessen Clever's plant. What is the name of that plant? Hessen Clever's plant. And the process works on the counter current principle. Counter current means what here? Rotating. One in one cylinder, one shaft is rotating, in another cylinder, another shaft is rotating, the third cylinder. So the total is called as the counter current principle. And here the slag lime is feed from the top. Slag lime is feed from the top. That means here onwards. Okay, and it moves down through various cylinders. Already I told. So here slag lime is moves down the first cylinder, second cylinder, third cylinder, fourth cylinder. Okay. Next, the chlorine gas is introduced from the near of the near the bottom. Here, this is very very important. Here, chlorine gas is introduced near of the bottom, not here onwards. Why? Because when the slag line is comes here, most probably the reaction is completely done here only. And if any excess chlorine gas is there, that one will goes into the upper cylinder, goes into upper cylinder, goes finally it will goes outside. That is the reason. But most probably 98 point percentage of chlorine is reacting with the slag line in this last cylinder only. Okay, the slag lime moves down, it reacts the chlorine gas to give the bleaching powder. The bleaching powder is collected in the barrels from the outlet in the lowest cylinder. Bleaching powder is not collected in the upper cylinder. Bleaching powder is collected in the last cylinder or the bottom cylinder, the lowest cylinder. Next, chemical reaction. So bleaching powder is prepared. What are the chemicals here taken? One is calcium hydroxide, that is known as slag lime, and the second one is a chlorine gas. So CaOH twice plus Cl2 gives rise to CaOCl2 plus H2O. Okay, CaOH twice plus Cl2 gives rise to CaOCl2 plus H2O. So here CaOH twice is nothing but slag lime or calcium hydroxide, and the Cl2 is chlorine gas, and the bleaching powder form is CaOCl2, CaOCl2 plus H2 plus H2O. See here, water is formed, so that's why if you touches that bleaching powder, the bleaching powder contains a wet nature because due to the presence of this water molecule, it does not contain a dry nature. Wet, you are feeling that if you touches the bleaching powder, you are feeling that it contains a water molecule. But really, it contains water molecules. So due to the presence of this H2O, okay. So once see that equation, CaOH twice plus Cl2 gives CaO Cl2 plus H2. Slag lime plus chlorine gas gives bleaching powder plus water. Let's watch the video. So here, while you are watching the video, once you have to recollect that previous diagram. That means this diagram. Here, this diagram is given like that. This diagram is given like this. Okay, but if you are observe the video in that video, the cylinders are present in this position. In this position, that means simple. I will tell one example in your home for okay. See here. It will be like that. See in home for making idli. For making that idli vessel is present. Vessel, and inside for placing that idli mixer here, some plates are present. Plates. Maybe three, first plate, second plate, third plate, fourth plate. So here for making the bleaching powder cylinder will be like that only. So here you assume that the plates are called as what your shafts, and you're on that idli plate, that idli mixer, where it is placing like that, you assume that slag lime is completely placed. So here that in that idli making vessel, okay, the plates are present on that place, that idli mixer is present. You assume that that idli mixer is completely called as a slag lime, and down onwards that heat is given to that vessel. You assume that down onward the chlorine gas is completely sent into that vessel. Like that you feel, not exactly, just for understanding purpose I was telling to you. Just when you are watching this video, automatically you are getting that idea. Okay, let's watch the video, see the video. See here. So here this is a cylinder. I told now here. You assume that this one is called as what here for making that idli vessel. And here one opening is through that opening calcium hydroxide is placed. Now inside the shafts are present. So see here. Okay. Calcium hydroxide dry slag lime is placed in this one. So here Okay, see here properly. So the dry slag lime is placed into this vessel. That means cylinder. So this white color is called slag lime or calcium hydroxide. And here these are known as what here blades. And this total disc. Okay, this is completely known as shaft, just like idli plate. So this is a idli plate, and this is called what your idli mixture. Okay. So see here. So see here how it is rotating. So see here this shaft is completely rotating, and when it is rotating, that what is that calcium hydroxide substance will comes down and falls into the next shaft. Okay. So see here one pipe is there. Through that pipe, chlorine gas is completely passes on this calcium hydroxide, otherwise slag lime. So see here. This is called as a chlorine gas. Chlorine gas is okay. Chlorine gas is completely passes. That means here the calcium hydroxide slag lime will fast down on this shaft, and next fast down. When it is coming down, on that time the chlorine gas is reacting with that slag lime. Okay, see here. See here also chlorine gas. Okay. But calcium hydroxide is falling down, and here the shafts are rotating. When the shafts are rotating, the calcium hydroxide is entering into that next shaft, and down onwards the chlorine gas is completely sent. And here the calcium hydroxide is like, which is completely faster. It is reacting with chlorine gas. So see here, chlorine gas is reacting with the slag lime. Okay. So your reaction will take place in the last shaft. So here finally chlorine is reacted and bleaching powder will be formed. So that bleaching powder is completely collected at the bottom position on barrels or otherwise on a vessel. Okay, this is about the making of a bleaching powder. And here hot air. Why they are sending means sometimes that a slag lime will become wet. So for converting that one into the dry nature, they are passing that hot air. Okay. See here that excess amount of chlorine gas and some waste gases, they are moving in upward direction. Finally, they will go outside. Water plus unused chlorine. Water plus unused chlorine. Why? Because they are sending that hot air means in that water will be present. And unused air, that means some amount of chlorine. Are you following or not? Following or not? Here, water plus unused air. So when the hot air is sent on that one, water molecules are present. So that water molecule and next unused chlorine. See here actually chlorine gas is completely sent at the bottom position. So on that time what happens that 98 or 95 percentage of chlorine is reacting with the slag lime, and the remaining percentage 5 percentage of chlorine gas is not reacted. So that is known as what is unused chlorine. So the water plus unused chlorine completely goes outside. Okay, that is a video of that making of the bleaching powder. Next, see here. Physical properties of bleaching powder. Here, two properties are present. One is a physical property, and the second one is a chemical property. Physical property is nothing but by observing, that means by seeing, by touching, by smelling. Most probably, without touching, what properties we are observing? All the properties are known as what your physical properties. So, first physical property of bleaching powder. It is yellowish white powder. Bleaching powder, yellowish white powder. Okay, but if you saw that bleaching powder, most probably it looks like a white color, but originally the bleaching powder which comes from that Hescherson plant, it is looks like a yellowish white color, and it gives a strong smell of chlorine. See here, for example, just amurtanjanam. Oh, you know what amurta jandu balm, you take the jandu balm and just place some amount of jandu balm near of your nose and observe the smell. You are feeling very strong, and it has a pungent smell. So that kind of nature is belongs to that chlorine. That means how Jandubam contains the strong nature, like that the chlorine contains the strong nature. So it gives a strong smell of chlorine. Okay. How chlorine is giving a strong smell, like that the bleaching pot is also giving a strong smell. That means immediately you are getting that what here vomiting. That means if you had a less resistance, definitely you will get vomiting. Or otherwise, little bit you have a little bit on that time you are getting some irritation on your stomach. Why? Because it has a very strong smell. Okay. Next, it is soluble in the cold water, not hot water. Separate you take hot water and place the bleaching pot. The bleaching pot is not soluble. That is just, so it is soluble in cold water. Cold water means just you take that rain water or otherwise tap water or otherwise freeze water. Just you take and place some amount of bleaching powder. 100% is soluble in that water. So that's why especially written that it is soluble in that cold water, not in that hot water, not in that steam. Next, okay, one more time. The physical properties of bleaching powder. It is yellowish white powder, and it gives a strong smell of chlorine. It is soluble in the cold water. These three physical properties are one mark questions in the CBSE board. So here the questions are like that. What is the smell of the bleaching powder? You must have to say that the smell of the bleaching powder is just like chlorine gas. What is that? Chlorine gas. And the other one more question is that what is the color of the bleaching powder? Here the color of the bleaching powder is yellowish white powder. One more question. One more question. Here the chlorine water is soluble in the which kind of that means where the bleaching powder is soluble. You have to tell it is soluble in that cold water. One more. Or otherwise, they will ask you to write the physical properties of bleaching powder. You have to write the three properties. What is that yellowish white powder? And it has a smell of the chlorine gas. It is soluble in that water. That means cold water. Here, what topics I was telling, each and every point, each and every topic is important to you. Because in the CBSE board, they will ask like that only. And all these topics are related. And yeah, this PowerPoint presentation, this video is completely made based on that CBSE paper. So watch carefully. And here the chemical properties of bleaching powder means how the bleaching powder is reacting with the chemicals and how they are reacting with the, what kind of chemicals. So see here, first reaction with carbon dioxide. Here, see here, this is important. Already I told that bleaching powder has a basic nature. What is the nature? Basic nature. And I told that when you have placed the red litmus paper, it is converting in the blue color. So the substance which converts the red litmus into blue color, that substance contains the basic nature. And here carbon dioxide. Carbon dioxide contains the acidic nature. So okay, reaction with the carbon dioxide. Here carbon dioxide. Here one point you keep in your mind that what is that bleaching powder contains the basic nature, carbon dioxide contains the acidic nature. So when acid and base are react with each other, compulse salt and water is formed. But here in this case, water does not form. Water does not form. So see here, CaOCl2. This CaOCl2 is known as a bleaching powder, and CO2 is a carbon dioxide. It contains a base nature. CO2 contains the acid nature. That means acidic nature. So base and acid react with the salt and water will be formed. But here water is not formed. What is formed here? Cl2. Chlorine gas is formed. And the salt is CaCO3. Calcium carbonate. And otherwise marble. Okay. Bleaching powder plus carbon dioxide gives calcium carbonate plus chlorine. Okay, this is the first chemical property. First chemical property. What is the first chemical property? Reaction with the carbon dioxide. Bleaching powder is reacting with the carbon dioxide. It will give the calcium carbonate plus chlorine gas. So again, by using this process, again we can prepare the chlorine gas. So here, one more important question is that by using which chemicals we can prepare chlorine gas? Reverse, indirect question. By using which chemicals we can prepare the chlorine gas? Bleaching powder and carbon dioxide. By using bleaching powder and carbon dioxide, we can prepare the chlorine gas. Next, second chemical reaction. Reaction with the dilute hydrochloric acid. So here this Cl2 contains base nature, HCl contains acidic nature. So salt, water, and chlorine gas is formed here. Okay, so bleaching powder react with the hydrochloric acid, gives calcium chloride. water and chlorine gas. So here that means in the previous reaction also, when it is reacted with the carbon dioxide, that means acid, it will give chlorine gas. Here also when it is reacting with the dilute hydrochloric acid, it will give the chlorine gas. But in the previous chemical reaction, water is not formed. But in this chemical reaction, the water is formed. Next, reaction with the sulfuric acid. So here CaOCl2, bleaching powder is reacting with the sulfuric acid, it will give the CaSO4. CaSO4 is nothing but calcium sulfate, water and chlorine. So this is a third chemical reaction. So finally, if you are observed, when the bleaching powder is reacting with any acidic substance, definitely it will produce chlorine gas. So this is a logical answer, keep in your mind. If bleaching powder is reacting with any acidic substance, okay, so here any acidic substance, that means CO2 is acidic substance, sulfur dioxide is also acidic substance, definitely will produce a chlorine gas. Chlorine gas. So these are the chemical properties. One more time. Reaction with carbon dioxide, CaOCl2 plus CO2 gives rise to CaCO3 plus Cl2. This is the first chemical property. Next chemical property. Reaction with the dilute hydrochloric acid. Bleaching powder plus hydrochloric acid gives calcium chloride plus water plus chlorine gas. Third one, reaction with the dilute sulfuric acid. Okay, bleaching powder is reacting with the sulfuric acid, it will give calcium sulfate, water and chlorine. So finally, if you are observing these chemical reaction, one product is common, that product is chlorine gas. Next, use of bleaching powder. So these are very very important. Used in the textile industry. Why? Because while they are making the textiles, on that time so much amount of dust is present, or otherwise in that dust, test in that textile, for removing that impurities, this bleaching powder is used. So bleaching powder is used in the textile industry. Next, used in the paper industry, when they are making that paper, on that time dust is present, and sometimes some soil making the paper into the different color. So for removing that color, so for removing the dust particles, the bleaching powder is used. Next, as a disinfectant and a germicide. So disinfectant, germicide, this is very very important. Now in this corona time, this is very very important. Why? Because killing of bacteria. Okay, as a disinfectant and germicide, it is not a, it is not causing any infection. It is not a infection substance, it is not infective substance, it is disinfectant substance. That means it is always protecting our body from that microorganisms, and germicide for killing the germs. So that's why it is used in the near of the drainages. Why? Because near of the drainages, so much amount of bad smell will come, and nice bacteria, germs are produced. So for killing that germs or bacteria, not to produce that bad smell outside. So near of the drainage, if you are place some bleaching powder, definitely the bleaching powder will stop the smell of that drainage, and it will kill the germs or the bacteria which are present in that particular area. So that's why here it is used as a disinfectant thermicide. Next, sterilizing drinking water. Sterilizing drinking water. So here, okay, sterilizing drinking water is nothing but for cleaning that drinking water. For example, here in your home, top up of that building, water tank is there. Water tank. So many years onwards you are using. When you are using that, the green color algae will be formed in that tank. So for removing that algae, if you are places the bleaching powder, what will happen? It will make that water into that purified water. So that's why it is used as sterilizing drinking water. Used in the manufacture of chloroform. This is very very important. Chloroform. Chloroform is used during the operation time. For making that operation near of that mouth, they will Pass chloroform. So if you want to make the chloroform composer, you must have to use this bleaching powder. That means not bleaching powder. For making the chloroform, bleaching powder is used. Okay. So here, small picture. An Indian government worker throws a bleaching powder for sanitization. One Indian government worker, municipality people, every time if any minister is coming or otherwise if any function is going, he is coming and he is placing some bleaching powder on the roads. Why? Because it will kill the germs and it stop the smell. So that is what your sanitization. Next assignment. This is your brain test. Okay, every time I was telling that this is your time. Yes, this is a brain test and this is your time. So watch that questions properly. Okay, here one thing you keep in your mind. All these questions are very, 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 very important. All what questions here given, all questions are mostly given in the different CBSE papers. That means Delhi board paper is present at like that. So from that papers that questions are collected. So if it is possible, you write in your class work. You get better, but important thing is you must have to answer the questions. First question. First question. A white powdery substance having a strong smell of chlorine is used for disinfecting drinking water supply at waterworks. Identify the substance, give its chemical name, and write the chemical reaction for its preparation. Wow, what a easy question. White powdery substance having a strong smell of chlorine is used for the disinfecting drinking water supply of supplied worker waterworks. Identify the substance. So here, what topics I was discussing? That is the answer for that question. Chemical name also you know very well, and write the chemical reaction for its preparation. So here, what is that? So acrylamide is reacting the chlorine gas. It will give the bleaching powder. Okay, you know very well, but that is the indirect question. Once you have to use your brains, use your two brains, small brain and big brain. What is the chemical name of bleaching powder? Bleaching powder is a common name. Here he asks, what is its chemical name? So already you know very well. That is the first topic. And what is the chemical formula of bleaching powder? Or otherwise, okay, not otherwise, chemical formula. So complete the following chemical reaction. So here, okay, see here. So see here, the fourth question, complete the following chemical equation. CaOH twice plus Cl2. This is the answer for the first question. And what product is formed? That is the answer for that. Answer for the second question and answer for the third question. So and here, what is bleaching powder? Bleaching powder is not a Pond's powder. Okay. What is a bleaching powder? That means you have to write the properties or use of bleaching powder. How bleaching powder is prepared? Right? Yeah, why the chemical equation involves the preparation of bleaching powder? These are only. What are the materials used for the preparation of bleaching powder? State 2 uses of bleaching powder. State 1 use of bleaching powder other than the bleaching. The bleaching is nothing but other than the cleaning purpose. Bleaching is okay. That means the cleaning purpose, not the removing colors, etc. Name the substance obtained by the action of chlorine on solid or dry slaked lime. What is the common name of the compound CaOCl2? Which compound of calcium is used for disinfecting drinking water? 12th one. With which substance should chlorine be treated to get bleaching powder? Name one compound of calcium which is used for bleaching cloth. What happens? Once you see here, 13th question and 11th. 11th and 13th. You know very well what you have to think it or other find answer from any book or other from the net. What happens when the bleaching powder react with the dilute sulfuric acid? Give equation, the reaction involved. What is the real bleaching agent present in the bleaching powder? So these are the important questions. 1 mark questions, 2 marks, 3 marks, 5 mark questions. So once you see a small topic on the topic, how many questions are there? Total 15 questions. The 15 questions are asked in a different manner. That is a CBSE science question pattern, CBSE science paper. I just said today I discussed only bleaching powder. See on that bleaching powder, how many questions are given? 15. 15 questions. One topic, 15 questions. And most probably, if you are after 80%, that answer is same only. Answer is same 80%. So here, while you are seeing the topic, while you are reading the topic, you have to think and you have to use your brains in different way. Why? Because we don't know in which way the CBSE the CBSE board will ask the questions in the science subject. Okay, that is about bleaching powder. I hope that you got the topics of the bleaching powder. So number of times you have to see that. We say number of times you have to see this video, and while you are watching that video, compulsory you have to use the headphone or otherwise earphones. Okay, then only that voice will reach us to your ears. So final, thank you. This one is nice. Thank you to all. Have a nice day. Bye 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 bye.